It's an IGCSE II, and we are actually doing surface area. For this one right here, we are doing the surface area of a cone. Now, I was going to draw the net for this, but I don't think that drawing the net for a cone is actually beneficial. It doesn't help you with anything that you need to actually solve the problem. So for this one right here, I'm just going to go through and explain where everything comes from. Now, right here, I have my picture of my cone. But the cone S actually stands for the slant height. H is the height, S is the slant height. So it's actually from the edge of the circle up to the peak. Edge of the circle up to the peak. It's not from the center of the circle to the peak. It's from the edge of the circle to the peak. So right here I have my radius. This is also very important, especially when I'm doing any type of circles. I have my radius. Now, my formula for the surface area here is actually pi r s. S is the slant height, plus pi r squared, which this is the formula for a regular circle. So that's what we need here. If you notice, I am not using the h. I wrote the h in here to actually show you the difference in between the height and the slant height. So slant height is the s, regular height is the h, and the height goes from the center of my circle straight up 90 degrees, where slant height is from the edge of the circle to the peak. Now, using that formula, let's go through and take a look at this next problem here. So I'm going to keep the formula right here. We have, let me see, my surface area is equal to pi. Now r, my radius here, and give it right here because it was kind of bunched up to cram in there. So it's going to be 18. S, which is 36. So there's my pi rs, plus pi radius 18 and squared right there. Here, let's clear this. Now let's take a look. I have pi parentheses 18 close open 36 close plus pi again 18 close square right here, and enter that, and I should get my surface area is equal to 3053 point. Now right here I'm looking at the 6. The 2 does not make the 6 go up, so it drops off from right there, so my answer is just going to be 0.6. Now let's see my units. These are all centimeters here. So if it's centimeters, it's going to be centimeters squared because area is always square. Now we're dealing with a surface area of a sphere. I've done my best to actually try and draw a three-dimensional sphere on a flat piece of paper. Doesn't come out very well, especially since I'm doing it in pen. Shading doesn't work out very well. Alright, so complain all you want. It's not going to get better. Alright, so I have my sphere. Okay, the only thing that I get from this that I need is actually going to be the radius. Radius is from the center of the sphere out to the edge. So it could be going in any direction, so the radius is just from the center to the edge. Now my formula for this is going to be surface area is 4 pi r squared. So 4 pi r squared. And trust me, I've tried to make a net of this to unfold it. It doesn't come out very pretty. So let's take a look. I'm going to use that formula for this example that I have right here. So for example 5, I'm going to have my surface area SA is equal to 4 pi. My radius is going to be 31 squared. Four pi 31 close squared. So I should get my surface area is equal to 1,2,0,7,6 point, if I'm looking right here, I'm looking at the 2, the 8 makes the 2 round up, so this is going to be 0.3. Now let's take a look at my units. My units are in inches, so that's going to be inches squared because it is area, surface area. Area is always square.